So we just saw that y equals x expresses a specific relationship. In the x or y coordinate system, it's a straight line where every point's x coordinate equals y coordinate. It's a straight line. Now, if I change the parameter a little bit and let's make it y equals 2x, what would that graph look like? For example, 1x is 1, y is 2, and 1x is 2, y is 4. And 1x is 0, y is 0 as well. So if I connect them together, it will look like this. Notice something. Every time x increases by a certain amount, y increases by a proportional amount, right? If x changes by 0.1, y changes by 0.2. If x changes by 10, y changes by 20. The constant, unchanging factor here is the ratio between the change in y and the change in x, which is 2. This property makes it a straight line. When I graph it, it's exactly like this. So why is this line special? For y equals 2x, I might want to draw another line. Let's say y equals 3x. So let's do it the same way. 1x is 1, y is 3, and 1x is 2, y is 6, and 1x is 0, y is 0 as well. So if I connect them together, it will still be the same. It will still be a straight line. So plotting those points, I see it's also forms a straight line, and it shares with the same property. For a fixed change in x, the change in y is constant. The ratio delta y over delta x is 3, and this line is obviously steeper. So what's the fundamental characteristics here? The differences lies in the line y equals kx, and the k is the ratio of the increments of y over x. So if I try y equals 4x, I would say 1x is 1, y is 4, and 1x is 2, y is 8, and 1x is 0, y is 0. So if I connect them together, it will be a steeper line. So every increase in y-x coordinate corresponds y coordinates of 4. So the ratio delta y over delta x is always the same. So the key variable for a line is its slope. When we look at a coordinate plane, the most essential feature of different line is their angle of inclination. The property is perfectly captured by the slope in y equals kx. The slope, defined as delta y over delta x, is constant for any 2 points on a straight line. Think about it. 2 points determine a straight line, right? And for any 2 points on the same line, is the slope always the same? Using some simple knowledge from algebra, finding any points on the straight line, and using the properties of similarity, it will say the angles are always the same. So the ratio between their delta y over delta x is always the same. So we will say the slope in one straight line between any 2 points is always the same. So let's say given you 2 points A11 and B24. Without graphing, can you find the slope of the line through them? Let's just try it. So the slope equals delta y over delta x, and delta y equals y2 minus y1. so y2 is 4 and y1 is 1, over x2 over minus x1. So x1 is 1 and x2 is 2, and we substitute them into the formula. It will be 4 minus 1 over 2 minus 1, and the value would be 3. So we will determine the slope of the line is 3. And this brings us to the next question. How do we find the equation of this straight line? First, a quick review. The standard xy coordinate system is divided into 4 quadrants, 1, 2, 3, and 4. Let's just focus on the first quadrant for now. The graph of y equals x is a line through the origin. Y equals x is a line through the origin. We can think of it as y equals x plus 0. So y-axis is 0, y equals 0 plus 0, and y-axis is 1, y equals 1 plus 0, y-axis is 2, y equals 2 plus 0. Now if I change it to y equals x plus 1, what happens? So y-axis is 0, y equals 0 plus 1 equals 1, y-axis is 1, y equals 1 plus 1, which is 2. So we'll see, if we experience 2 points here, and if I connect them together, it looks like I move the straight line up for 1 unit. And let me do another line. Y equals x plus 3, so one x is 0, y equals 0 plus 3 equals 3. Y-axis is 1, y equals 1 plus 3 equals 4. So it looks like I'm moving the straight line up to 3 units. So for any line, I can write it as the general formula as y equals kx plus b. And let's ignore k for a moment. Just focus on b. We call b the y-intercept. It's helpful to think of it as a starting point from the y-axis. It's a y value when x equals 0. From this starting point, the growth rate is determined by its slope k as delta y equals k times delta x. And now we have the complete picture for a line y equals kx plus b. K is the slope of the line describing the steepness, and b is a y-intercept, the starting point on the y-axis. So how do we actually find the equation? Let's still find the points a, 1, 1 and b, 2, 3. First, try to figure out the slope. K equals delta y over delta x, which y2 minus y1 over x2 minus x1. It will be 3 minus 1 over 2 minus 1. The slope of the straight line would be 2. And the slope means every unit x increases corresponds to y increase of 2 units. And now, we could set any straight line form as y equals kx plus b, and the slope is 2. How do we find the value of b? We could substitute any point into the equation. A or b is fine, and I substitute a. So it will be 1 equals 2 times 1 plus b. I will get the value of b is minus 1. So the equation of this straight line would be y equals 2x minus 1. The negative intercept means the line crosses the y-axis below the origin. And if I draw this straight line, it will look like this. It starts from O minus 1 with a steepness of 2. Every increasing x corresponds to 2 increasing y. So it will look like this. Let's practice with another example. Given you 2 points A, 2, 2, and B, 3, 7. First, try to figure out its slope. Its slope would be delta y over delta x, which is 7 minus 2, 3 minus 2, it would be 5. And using y equals kx plus b, we already know its slope is 5, so it's 5x plus b. And we can substitute any point. Now this time let's try b. We can substitute the value of y and x into this equation, so it will be 7 equals 5 times 3 plus b. So b would be minus 8. And the equation of the straight line would be y equals 5x minus 8. So this method first find the slope and then the intercept is very logical. That's a very common method of setting up a system of equations. And finally, let's think about parallel lines. What do parallel lines have in common? You see, if I draw one straight line and I make another line parallel to it, and I'll draw the search line parallel to them, what will be the similarity between them? Well, the angle of their inclination is the same, meaning their slopes, k, are identical. If lines have the same slope but different y-intercepts, let's say you see they start from different points of the y-axis, they are parallel but distinctive lines. For example, this could be y equals x plus 1, this could be y equals x, and this could be y equals x minus 3. They all have the same slope, but different starting points on the y-axis. So to sum up, understanding lines is very fundamental. In coordinate geometry, any graph is essentially one of two things. Either it's a straight line or it's not. If it's not a straight line, what will it be looking like? We could dig deeper into whether it's a parabola, a hyperbola, or something else. But the first and most important check is always, is this a line?